Everyone, welcome to Pulla's Academy. This is physics class for ESET students by Kiran Kumar Adarapu. So today concept is a part of units and dimensions. So here the blueprint of this lesson is 2 marks. That means we have to expect 2 questions in ESET exam. Okay, now? So today we are going to discuss about the part 2 video in units and dimensions. Here we will discuss some important conversations for numericals. యాక్చువల్లీ ప్రాబ్లమ్ సాల్వింగ్ అనేది కరెక్ట్గా చేయాలంటే మనకు కొన్ని బేసిక్ కాన్సెప్ట్స్ అనేటువంటి అవసరం. ఆ బేసిక్ కాన్సెప్ట్స్ అన్నిటినీ నేను ఈ వీడియో ద్వారా మీకు ఇవ్వడం జరుగుతుంది. వీటిని మీరు క్లియర్గా అర్థం చేసుకొని అవసరం అనుకుంటే ఏం చేస్తారు, నోట్స్ అనేటువంటిది మెయింటైన్ చేయడం వల్ల మీరు ఇంకా క్లియర్గా అటెంప్ట్ చేయడానికి అవకాశం ఉంటుంది. కనుక అవసరం ఉన్నటువంటి పాయింట్స్ అన్నిటిని ఖచ్చితంగా మీరు నోట్ చేసుకోండి. ఓకే, దాని ద్వారా ప్రాబ్లమ్ సాల్వింగ్ అనేటువంటి చాలా ఈజీగా అవుతుంది. సో ఇప్పుడు నేను ఏవైతే చెప్తున్నా అవి చాలా ఇంపార్టెంట్ కాన్సెప్ట్స్. ఇది ఈ లెసన్లో ఉన్నటువంటి కాన్సెప్ట్స్ కావచ్చు. ఈ బేసిక్ కాన్సెప్ట్స్ అనేది ప్రతి టాపిక్ ప్రతి లెసన్కు రిలేటెడ్గా అవసరం ఉన్నటువంటి అన్ని బేసిక్ కాన్సెప్ట్స్ అనేటువంటి ఇక్కడ మనం డిస్కస్ చేయడం జరుగుతుంది. వాటిని గుర్తుంచుకోండి. ఓకేనా, రైట్. Now we are going to discuss about some important conversations for numericals here. Okay, now so in the numericals the values are not giving in SI. Sometimes they are giving in different multiples and submultiples, sometimes given by different special units. So that's why how to first actually if you want to solving the numerical, first we need to conversion from one system into another system. That we need some conversations. That's why we need to recognize these all conversations. Okay, now the first conversation is, so here kilometer for hour here. So here we have to understood but the first conversation is 1 kilometer per hour. kmph stands for kilometer per hour. 1 kilometer per hour is always similar to 5/18 meter per second. This is one of the important conversation. Actually kilometer per hour, this is kilometer per hour. It is a unit of velocity. So meter per second is also unit of velocity, but it is a SI unit, whereas kilometer per hour is a large unit for velocity. So that's why 1 kilometer per hour is similar to 5/18 meter per second. Okay, if you want this derivation, actually 1 kilometer per hour stands what here? 1 kilometer by hour. That means kilometer stands 1000 here. Actually 1000 meters, 1 kilometers. 1 hour is 3600 seconds. If you simplify 2 5s are 2 18s are, so it is similar to 5/18 meter per second. That means 1 kilometer per hour is equal 5/18 meter per second. In this way you have to understood this conversation. The next important conversation is, the second one is 1 Newton. Capital N stands what? Newton here. 1 Newton is similar to 10 power 5 dynes. What is the value? 1 Newton is similar to 10 power 5 dynes. Newton is a unit of force. This is a SI unit, but whereas a dyne is a CGS unit, 1 Newton is always similar to 10 power 5 dynes. This is one more conversation. Okay, so in the same way one more conversation is, the third one is 1 joule. 1 joule is similar to here, 1 joule is similar to 10 power 7 ergs. 1 joule is similar to what? 10 power 7 ergs. This is one more conversation. What is joule? Joule is a unit of work done or energy. So this is a SI unit, whereas erg is a CGS unit. So what is the relation between joule and erg? Sometimes the given energy in terms of ergs, but we need in joules. So if you know this relation, then very easily conversion from 1 joule into so then that erg is conversion into joule. 1 joule is equal 10 power 7 ergs. Right. Next we will discuss one more conversation, that is 1 calorie. 1 calorie is similar to So 4.18 joules, exactly 4.18 joules are nearly equal 4.2 joules. So calorie is the unit of heat energy. This is CGS unit, whereas joule is the SI unit of heat energy. What is the relation? 1 calorie is equal 4.18 joules. Sometimes here instead of calorie 1 kilocalorie is given. Kilo stands for 1000. So 1000 into this, that is similar to 4180 joules. This is 1 kilocalorie is equal 4180 joules, or 1 calorie is equal 4.18 joules. This is one conversation here. Okay now. So next one more conversation here. This is liter. 1 liter. Okay now. So liter is actually it is a unit of volume. This is a general unit. But what is the SI unit of volume? Meter cube is the SI unit. So if you want to conversion into meter cube, so in CGS the unit of volume is centimeter cube. Okay now, what is the relation here? It's very important relation here. 1 liter is similar to here, this is 10 power 3 centimeter cube. What is the value? 10 power 3 centimeter cube. 10 power 3 stands for 1000 centimeter cube. 1 liter is equal 1000 centimeter cube. Whereas it is similar to 10 power minus 3 meter cube. 10 power minus 3 meter cube. 1 liter is equal 10 power minus 3 meter cube is a relation. Meter cube is SI unit. This is CGS unit. This is a general unit. So these are the relation among these all units. Sometimes the volume is given in liter, but in the problem solving we have to conversion into SI. After that substitute in the formula. So then how can you conversion into meter cube? 1 liter is equal 10 power minus 3 meter cube is the relation. Okay now. Next, after that we will discuss one more relation, that is 1 electron volt. EV stands for electron volt. 1 electron volt is equal to 1.602 into 10 power minus 19 joules. What is 1 electron volt value? So 1.02 is not, just write 1.6 is enough. 1.6 into 10 power minus 19 joules is the relation. 1 electron volt is equal. Electron volt is a unit of heat energy, electric energy. Joule is also SI unit. This is a general unit. Okay now, 1 electron volt is equal to 1.6 into 10 power minus 19 joules. Joules is a SI unit. It is a general unit, especially for electric energy using this unit, but joule is using for any energy. This is a SI unit. This is a standard unit. So that's why we need to understand the relation between this SI unit and this general unit. Okay now, next, sometimes for electric energy using this unit also, that is kWh, kilowatt hour. So 1 kilowatt hour is, what is the value? Kilowatt hour is also unit of electric energy. So this 1 kilowatt hour is equal to 36 into 10 power 5 joules. What is the value? 36 into 10 power 5 joules. Okay now, so if you need this derivation, 1 kilowatt hour is equal, kilo stands what here? 1000 watts. Hour stands 3600 seconds. This is similar to 36 into 10 power 5 watt second. Watt second is similar to joules. That means 36 into 10 power 5 joules. That is the relation between kilowatt hour and joules. Okay now. Okay. One more conversation. 1 horsepower. HP stands for horsepower. Is equal. It is a unit of power. The unit of power is one of the actual SI unit is what? Horsepower is the multiple of what? 1 horsepower is similar to 746 watts. What is the unit? 746 watts is a relation. Okay now, so next one more conversation, that is kilogram weight. KGWT stands for kilogram weight. is equal to 9.8 newtons. What is the relation? 1 kilogram weight is equal to 9.8 newtons. So one more conversation, that is 1 gram centimeter inverse cube is similar to 1000 kilogram meter inverse cube. Okay, now 1 gram centimeter inverse cube is equal 1000 kilogram into meter inverse cube. This is actually gram centimeter inverse cube is a unit of density. This is a CGS unit. This is a SI unit. So the relation is what? 1 gram centimeter inverse cube is equal 1000 kilogram meter inverse cube. Here you need to recognize one value important. What is the density of water? Density of water is a known value, that is 1000 kilogram meter inverse cube. In the problem sometimes it is not giving. You have to recognize density of water is 1000 kilogram into meter inverse cube, or in CGS 1 gram centimeter inverse cube. The density of water in CGS 1 gram centimeter inverse cube, or in SI 1000 kilogram by meter cube. This is the density of water is a known value. Okay, now so one more conversation, that is 1 Tesla. Tesla is a unit of magnetic induction, so it's denoted by capital T. 1 Tesla is equal to 10 power 4 gas. 10 power 4 gas. So this is one of the conversation. Okay, now one more conversation, 1 Weber. 1 Weber, it's denoted by WB. It is similar to 10 power 8 Maxwell. Okay, now so this is Weber is a unit of this is unit of magnetic flux. 1 Weber is equal to 10 power 8 Maxwell. So these all are the important conversations here. Mainly in the problem solving, this kilometer per hour, Newton, and here calorie. This is so here this horsepower, the motor vehicles power is measured in horsepower, but we need to conversion into watts, so use this relation. So and one more is what density unit is gram centimeter inverse cube is equal in SI 1000 kilogram meter inverse cube. So these all are the important conversations, so you have to recognize as it is. So if asking any question, any in the problem is not given directly in SI values, given in kilometer per hour, otherwise otherwise given in any different units. So if you know these all important conversations, if given any question based on this concept, very easily attempt, otherwise it's not getting correct answer. Machine should focus on this area. Okay, for problem solving, one more very important concepts. Okay, now so that is what we need to understood. So actually in the given question, sometimes the given values are not in the SI, they are given in some different prefixes. These prefixes are represents the submultiples and multiples. Okay, now so we need to understood the prefix values. Okay, now based on this table, understood very easily, understood what is the value of this prefix. Okay, now so I want to explain clearly about these prefix values based on multiples and submultiples. Okay, now so first this tabular form is very important for all problem solvings. Okay, now so machine should concentrate here. So here for first we have to discuss one prefix, that is one submultiple. Submultiple means what? It is a small, when use this submultiple, you get a small value that is compared to the SI value. When we use this prefix, so this multiple is used, then you get the large value to compare the SI value. That's important. So for example, one of the multiple is DC. One of the multiple is what? DC. Okay, now this prefix is simply is denoted by small d. Small d always we call what? DC. So what is the value of this prefix here? 10 power minus 1. So this prefix value is what? 10 power minus 1. So small d we call DC, its value is 10 power minus 1. Whereas it's a similar multiple. So 10 power minus 1 stands what here? That is 1 by 10. 1 by 10 means 10 parts of 1. So here that is called as a DC. In the same way, deca. So deca is denoted by DA. DA we call what? Deca. So it is not submultiple, it is multiple. Why? Because its value is similar to 10 power 1. 10 power 1 means 10. That means 10 times is greater to compare the given unit. So when we use this multiple, you get 10 times is more than the unit. When we use this submultiple, you get 10 parts of the given value. It is similar to, this is about DC, this is a deca. That's the difference. Okay now. So the next one is, so the second one is centi. Second submultiple is what? Centi. It's, this prefix is denoted by small c. Small c we call what? Centi. Centi value is what? 10 power minus 2. Its value is 10 power minus 2. That's the important. Centi is one of the prefix. This is one of the submultiple. Its value is 10 power minus 2. It's a similar prefix. In multiple is hecto. So it's denoted by H, that is similar to 10 power 2, that means 100. Hecto means it is similar to 10 power 2, means what? 100 times is more than the given value when we use this prefix. This prefix we call hecto, its value is 10 power 2. Sometimes using this symbol centi. So generally in CGS the length is measures in centimeter, cm, write like this. In this units, meter is a unit actually. Before meter, using this prefix, this is prefix, c is the one prefix. This prefix is called centi. Its value is what? 1 centi is equal 10 power minus 2 meter. So this prefix always write before any unit, not only write before meter. Suppose if you write centi-g, cg means what? Centigram. 1 centigram is equal 10 power minus 2 gram. So that's the point. So otherwise write cs, centisecond. So that means 10 power minus 2 second. In this way, these all prefixes always write before any unit, you get the value. So this centi value is 10 power minus 2. In this way you have to understand. Next, one more important here, the centi. Next important value is milli. This is also using so many times we have. So milli. Milli is denoted by small m, not capital M. So milli is one submultiple. This prefix is denoted by small m. This prefix value is 10 power minus 3. What is the value of milli? 10 power minus 3. Whereas its similar multiple is kilo. It's denoted by K. Its value is 10 power 3. Kilometer. Generally we use this unit. Kilometer stand 1000. This is 1000 meters. Kilogram also using, kilogram means 1000 grams. So these are the relations. So one more important unit, this is micro. So it's denoted by this symbol is called mu. We call micro. 1 micro stands 10 power minus 6. Its value is what? 10 power minus 6. This symbol always we call micro. What is the value of micro? 10 power minus 6. Okay now, its similar multiple is mega. So it's denoted by capital M. Small m stands milli, capital M stands mega. Mega value is 10 power 6. Here a large difference between small m and capital M values. This is milli, this is mega. Don't use instead of small m capital M. Okay now, so that's the point. Next, after that we will discuss one more important submultiple, that is nano. Sometimes using n, it's denoted by small n, that is 10 power minus 9. What is the nano value? 10 power minus 9 is the nano value. Okay now, so in the similar value is, so here giga. This is what? giga. Giga value is, it's denoted by capital G. Its value is 10 power 9. 10 power 9 times is more. Okay now. So next one is here pico. It's denoted by rho symbol. This is like, right, like this. This is pico value is 10 power minus 2. Its similar multiple is here, that is tera. It's denoted by capital T, that is 10 power 2. Suppose water is measures in TMCU, that means teramycin unit. So that is tera value is 10 power 12. 10 power 12 is very large value. It's not value, not small value. That's why 1 TMC is not small value. So that's very large value. Based on this value, very easily understood. This is one more value, that is femto. So this femto is denoted by small f. So its value is 10 power minus 15. It is similar multiple is peta. So it's denoted by capital P, that's value is 10 power 15. These are some submultiples and multiples. Okay, I hope you understood. So but sometimes here, so actually these are the important multiples and submultiples. Sometimes some important multiples and submultiples are, some important prefixes are using. Actually instead of these prefix, sometimes using some more important prefix. So that is, these are majorly using one is called as angstrom. So angstrom is denoted by A, right, like this. So 1 angstrom value is 10 power minus 10 meter. Angstrom is unit of length. So 1 angstrom is equal to 10 power minus 10 meter. That means it is very small unit. Meter is SI unit, angstrom is a small unit. 1 angstrom value is 10 power minus 10 meters. If the given length in angstroms, don't substitute directly, first conversion into meter by using this relation. So then after that substitute in the formula. Okay, now one more unit is, so Fermi. So it's denoted by capital F. 1 Fermi is equal to 10 power minus 15 meters. 1 Fermi value is what? 10 power minus 15 meters. Okay, now this question is asking one time in the ESET exam. 1 Fermi is equal to dash meters, that is minus 15 meters. Okay, now so one more is micron. So micron is also, it's denoted by mu m, micrometer. Micron means micrometer actually. That means 10 power minus 6 meter. Only micro stands 10 power minus 6. Micron stand, it is a unit of length. 1 micron is equal to 10 power minus 6 meters. Okay, now so, and one more important prefix, that is light year. Light year. What is light year here? The light traveled in 1 year. The light traveled in the vacuum in 1 year is called as light year. That means based on the definition, light year is not a unit of, it is not a unit of time. So it is unit of distance or unit of length. Okay, now because based on the definition, the light traveled in the vacuum in 1 year. So that is called as light year. But it is, from this word maximum students are understood, it is unit of time, but it is not a unit of time. Okay, now 1 light year is similar to 9.46 into 10 power 15 meters. It's a very large value. 9.46 into 10 power 15. So here meters, this is a distance. Okay, now so these all are the some important multiples and submultiples. Okay, now right, now we are going to discuss some important physical constants and their values. These are very important. So one of the unit is AMU. It is unit of mass. It is a small unit. Actually 1 AMU is always similar to 1.67 into 10 power minus 27 kilogram. Okay, now so this is a 1 AMU value in kilogram, that is 1.67 into 10 power minus 27. So this much of mass is similar to 931.5 million electron volt. MeV means million electron volts. Its equivalent energy is 931.5 million electron volts. Okay, now atmosphere is a unit of pressure. Actually SI unit is Pascal, but 1 atmosphere is equal to 1.013 into 10 power 5 pascals. This is a relation. Okay, now Avogadro number, it is one fixed number here. This in Avogadro number is 6.023 into 10 power 23. This is a Avogadro number. Next, whereas Joule's constant value is 4.18. 4.18. So Joule by calorie, it is a Joule's constant J value. Planck's constant value is 6 here. This is similar to 6.62 into 10 power minus 34 joule into second. This is Planck's constant value, 6.62 into 10 power minus 34 joules, whereas Boltzmann constant Kb, in heat topic we will discuss. These are all values we will discuss in different lessons here. Okay, now but if I explain at one place, you have to recognize very easily. That's why I won't explain here, but we will discuss each and every value in different concepts here. So this Boltzmann constant value is 1.38 into 10 power minus 23. Okay, now its unit is joule Kelvin inverse. One more is universal gas constant. This universal gas constant value is 8.314 joule mole inverse Kelvin inverse. Okay, now one more important value, so that is unit of capital G value. Capital G stands for universal gravitational constant. Its value is here, what is the value? 6.67 into 10 power minus 11 Newton meter square kg inverse square. These are the important values. One more is important value is charge of electron. That's is also known value, charge of electron. So you want to recognize this value, that is denoted by E. E is equal to 1.6 into 10 power minus 19 coulombs. So these all are the important physical constants and their values. Okay, now so recognize as it is. Okay, now we are going to discuss some previous ESET questions here. So previous repeated questions. One question here, one repeated question. This is ESET 2016 paper. So in ESET 2016 paper, one question is, with respect to the suitable conversion units, the values of the following blanks respectively. Here given two blanks. We have to find out this values. Here one is given 1 kilogram meter square second inverse square is equal dash gram centimeter square second inverse square. Second one is given 3.0 into meter second inverse square is equal dash kilometer into hour inverse square. Given these are the options here. So here we need the solution. Here it's not understood directly. So what is the solution here? The first one is given. So 1 kilogram meter square second inverse square. So 1 kilogram here given in grams. 1 kilogram, how many grams here? Instead of kilogram write grams, then 1000 grams. Meter is centimeter square. 1 meter is equal to what here? 1 meter stands 10 square. That means 1 meter is equal to 100 centimeter. 100 means 10 square. So this is centimeter square. That means right here square. Okay, now meter square is equal to 10 square. So here whole square. If you confuse, then right here 1 meter means 100 centimeter whole square. This is the procedure. into second. Here also second, that's why write as it is. Now if you conversion, this is 10 power 3 here gram. So this is 100 centimeter whole square. 100 means 10 square, whole square is what? 10 power 4 centimeter square into second inverse square. If you simplify, this is 10 power 7 gram centimeter square second inverse square. This is the blank here, 10 power 7 gram centimeter square second inverse. This is the first answer. So the here the second solution I want to explain here. So this is what is given, 3.0 meter second inverse. It is equal to kilometer hour inverse square. Okay, now meter second inverse square. This is kilometer. We know the relation between kilometer and meter. 1 kilometer is equal, listen to me, actually 1 kilometer is equal 1000 meters. But here we need meter is conversion into kilometer. That means write as a subject meter. This 1000 is shifting. That is 1 by 1000 kilometer. 1 by 1000 stands 1 by 10 cube. That means 10 power minus 3 kilogram. Kilometer. So that means here if you conversion like this, so in the same way this is second, hours. So actually 1 hour is equal 3600 seconds. But here 1 second is equal 1 by 3600 hours. Okay, these two substitute here, you get the answer here. Actually here 3.0 means 3 into, so meter is equal, right here this is 10 power minus 3 kilometer. Next second inverse square. This is second inverse square here actually. So second inverse square means by second square, that means. So that means divided by second square. Second is equal to this. That means 1 by, this is similar to 3600 hours. Second is equal whole square. If you simplify this value, 3 into 10 power minus 3 kilometer by 1 by 3600 hours whole square. After simplification, you get 3.88 into 10 power 4. So, kilometer hours inverse square. Okay, this hours square is shifting into numerator. Then hours inverse square, that means 3.88 into 10 power 4. If you simplify, this is 3 into 10 power minus 3 kilometer by 1 by 3600 hours whole square. That means 1 by 3600 whole square is divided by, after simplification. So finally you get this answer here. So this is a conversation into in this way. So this is about the solution. Okay. Right. So one more question here, simple questions here. One more is 1 Fermi is equal dash meter. This is also previous ESET question. What is 1 Fermi? Already I explained here. This is similar to 10 power minus 15 meters. Simple question here. This is. So this is also one more simple question. 1 kilowatt hour. If you know, that's very simple. 1 kilowatt hour is 36 into 10 power 5 joules. Already I explained this derivation. So 36 into 10 power 5 joules. This is a relation. 1 light year also I explained. What is the light year value? 1 light year value is what here? 9.46 into 10 power 15. So these are the different. This is also previous question. So these are the previous repeated question on this area. I cover these all concepts. Okay, now. So in the next video I want to explain very important concepts in this lesson. So that is dimensions. So most important expected area. So don't miss. So in the next video we will discuss that concept. Thank you. Bye.